So let's say we have a number 50, an integer number, and we want to print it out to the terminal. Well, we can use printf with the D format, and it's gonna print out 50, right? The number we're looking for. But if we use fwrite instead of printf, and if we try to print that, it's gonna print out some weird characters, 4 characters, 1, 2, and then 3 weird characters. So what's happening here? Well, we are printing all the bytes in I, so we even have 4 of them, right? Since int in my system is 4 bytes. But the thing is, well, they are interpreted as characters, right? And the 2 here comes from, well, if we look at an ASCII table, look at 50. So decimal 50 is actually the ASCII character 2. But what about these? Well, they're probably the zeros, the leftover zeros on the left side of 50, right? Because when we have 50 here in binary, it's like, I don't know. Let's just say this is 50, right? Let's say this is 50, and then let's say we have 32 bits, or the amount of bits that are in an int, right? So these are the bits representing 50, and since an int can actually represent a large number, the rest are just zeros, right? And so they are just zeros, and so since 0 in ASCII is the null character, when we try to print it, we have 3 null characters here. And why does printf work? Well, printf is a high-level function which will interpret your thing here, whatever format you are specifying, and then probably turning them into characters first, before actually printing them into the terminal. So when we have 50 here with %d, well, it's probably gonna do reverse stir to long to stir or something, where it's going to turn it into 50, the characters 5 and 0 first, before actually printing it out into the terminal. And so when you want to print numbers into the terminal, what you actually want to print is the characters representing them, not the actual numbers. Because if you try to print the actual number 50, well, what you'll get is the ASCII of 50, right? The ASCII character, which is 2.